push that rock with Simpson Math. Let's talk about graphing logarithms. So first we'll remind ourselves what a logarithm is. It's the inverse of an exponential function. We let the base be some positive number but not 1, because 1 would be boring. 1 to any power is always 1. So positive number but not 1. So it can be a fraction like a half or a big number like 100. So we have b to a power equals some. We call this the power. We actually call this the exponent, but frequently we kind of confuse power and exponent. But 2 to the third power is 8. 8 is the third power of 2, so 2 to the third exponent is 8. But anyway, language being what it is, that would be log base 2 of 8 is 2 to what power, what exponent gives me this third power, 8? Well, it'd be 3. So that's the definition. B to the p equals a, log base b of a equals p. Okay? Now we're going to use this definition and the fact that logs are inverses of exponentials to graph something as simple as log base, say, 1/2 of x. And what we're going to do is find the inverse. So we let x take the place of y, and we take x and replace it with y, because remember, inverses interchange the x's and y's. And now we undo this with the definition. Remember, if we have b to the p equals a, then log base b of a is p. So in this case, this is the base, so 1/2 to the x power is equal to the y. So here's the inverse of this function. And I'm going to get values on this graph. And I can put in any x value, so I'll make sure I put in negatives and positives and 0. So what if I put in -2? What if I put in 0? What if I put in 2? Well, if I put in -2, 1/2 flips to 2. 2 squared is 4. If I put in 0, any non-zero number to the 0 is 1. If I put in 2, well, then I get 1/2 times 1/2, which is 1/4. Now that means that's on this graph. So all we have to do to find points on this graph is to invert our x's and our y's. We just got to invert our x's and our y's. So I'm going to take this 4 and make it an x, and this -2 make it a y. Take this 1, make it an x, take that 0, make it a y. Take this 1/4 and make it an x, and make that 2 a y. Okay, so now we're ready to graph the function. You know, maybe we need more points than that. You know, if you're a beginner, you might ought to get a few more points over here. Okay, but I think we can do it. 4, -2, 1, 0, and 1/4, 2. So let's remember those points. It was 4, -2. It was 1, 0, and it was 1/4, 2. Those are our points on the logarithm graph. So we'll get out a Cartesian plane. I really don't need much move over here because we're graphing y equals 1 log base 1/2 of x. Well, the argument of a log must be positive, so I can only put in positive values over here. So 1, 2, 3, 4. When I go over 4, I'm at -2. When I go over 1, I'm at 0. So this is 4, this is 1. Now, and I'm using these marks for, okay. And when I go to 1/4, that'd be about right here, I'm at 2. Now, if that's not enough for you to figure out the pattern, well then do more points on the inverse and then interchange more points. But I happen to know a lot about logs. I know that the domain of this log is wherever the x is greater than 0. And I know that the edge of the domain is where you're going to have a vertical asymptote. So at x equals 0, it would be a vertical asymptote on this y-axis. Remember, x equals 0 is a vertical line. Okay, so there's a vertical asymptote there. So I know it's doing this. Now, the reason why this is decreasing is because my base was a fraction. If my base was larger than 1, well, then I'd have something that's coming up like this. But this one has a base that's smaller than 1, so it's going down. So it's going to go down. And then the other thing I know about logs is they flatten out. So they do not have a horizontal asymptote. This will go to negative infinity. If I go out far enough on the x-axis, the y values will go to negative infinity, but they go there very slowly. And so it looks very flat. And there's the graph of a logarithm. Math made simple at Simpson Math.